YouTube. Okay, I think I'm live. Today we are going to solve some problems on dynamic programming. Yesterday we have done some problems on 1 dB and we will continue one question on that and we will see. Let's get dive into. Okay, so we have solved the problem house over 1 yesterday. That question is similar to the adjacent sum, non-adjacent sum. Now for this question with so what we have here, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses are security system connected and it will automatically connect the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so X carry drop. What? How do I clean all of this? Okay, so in previous question house number 1, what we have here is that we don't have all the houses arranged in circle. Means the first house not connected to the last house. They are arranged in a linear row, like starting from 0 indexed. It's wide and dark. One, 2, 3 and 4, 5, like this. This is the indexes, and let's take an example. 3, 2, 4, 5, 6 and 3 again. So how we can get the maximum money we can rob from all these houses? There are 6 houses. This is for the house plan 1 that are arranged in a linear row. Okay, so if we start from the index 0, we have done through the recursion. We are also use the memoization, and then we converted that solution into tabulation, and also we have space optimize the space. If you see the previous question like this, I'll show you the solutions like this solution. This is a basic recursion solution. So this is getting as TLE. Like what we have done is that this is a base condition. If the index becomes greater than n, then what we're gonna return is 0, because if we go outside the house's boundary, then there will be a 0 sum. And then what we have done here is that we have done the two step recursion. Like there is two thing that you can done when you are solving these kind of problem. There will be that you have to pick or not pick, that you are on the first house, you can take the rope this house, and you don't rope this house. Then what are you gonna do is that if you rope this house, then you can't rope this house because the security conditions. Then you can rope this house and this house, anything that you can do, but you can't rope the adjacent house. So if you rope 3, then you can rope 4. Okay, we will take it 4, and you can't rope 5 then again. Then you can rope 6, then you rope 6, then you can add 3 plus 4 7 plus 6 is 13, but you can't rope 3. Okay, so that will be the 3 4 7 and 13, that will be the 13 total sum. Okay, so if you don't take 3, then what you're gonna do is that you can take 2. Okay, we can take 2, we take 2, but you can take 4, because that is the adjacent. And you can, if you take 5, then you can have this 7 and 3, then you can get the 10 sum, which is smaller than the previous one. Okay, so and then we will try all the subsequences, like by taking 2, by taking 6, by taking 3, with all this by using recursion, and we will get the maximum sum in this way. And that's our code. If you steal, then you can get the input, not input, the indexed array value, and you have maximum you call the recursion function for the next neighbor, means second index from the house you have robbed. Then you can give the function. And if you not steal from that house, then what you can do is that you can call max function, max cache function, but in this condition you can rob the adjacent, because you haven't taken the you haven't robbed the previous house. Then you can take the next house, not the adjacent. Not means you can take the adjacent house money, and then you can compare the maximum sum from by stealing or not stealing the house. If you get more in stealing, then you can return that. If you get more in non-stealing, then you can return that, and that will be your output. But here what you are doing is that you are finding all the subsequences which will be getting your 2 to the power n time complexity, and which is not ideal way to solve question. Then what we have done is that we have applied the memoization. Means if you have that's the DP, means when you have already computed some recursion previously, and you are going to compute again that recursion, then uh, no benefit in computing again that solution. So what we're gonna do it, you can store in any array which we can call dp, and put all these sum or index sum that function sum that are coming from the computing the recursion. And if we found that recursion again, then we can take it out from the dp and use in our function. Like this base condition, if we here we have initialize the vector given return the function, and here what we have is that dp if equals to not equals to 1 means we have initialized the dp all dp sums is equals to -1. But we have found that if dp is equals to not -1, then what we're gonna done is that dp dp sum at that index, because if we haven't if we not have the value that we have initialized first, then this means that we have already solved that problem, solved that recursion or function. So we don't have to repeat itself, because it will be time consuming, and we have to resolve the time complexity. Then there is also the condition. This is the condition for the recursion. You take or not take, and if you take, then this is the function. If you not take, this is the function. This is I+1 and I+2. And this will return the solution, and it will taking the time complexity is of 0n, and this dp but this dp taking the space complexity of n size for the using this dp vector. It's taking n space complexity, and also the n complexity for the vector norms. Then this is taking the 2n space complexity. So so what we can do is that we can resolve by using the tabulation. By tabulation, what we can do is that we can reduce the space complexity from 2 into n to 2. Am I making sense? I think so. So in that solution, what we have done is that we haven't used the this recursion, because this recursion technique are getting us 0 to power 0 n time complexity, because it's taking the stack memory size. Then what we can do is that in place of using this function, we can directly call the dp's. Wait a minute, I think I haven't given the solution of that. Okay, so how can I show this solution? But I can solve the so I can show the solution that is better than that, because it's taking the constant space complexity and time complexity. That is the best solution you can get from the Haushofer solution. So what we have done is that is a very simple solution. You have initialized two integer variables, and there's a trick on tips that you can follow when you have when you have to get or compute. You have to compute the answer that you can calculate by using the previous and the next previous value. Then you don't have to be get all the values. You have to store all the previous values. So you can do what you can do is that you can shift or return. That's not my solution. What? Okay, here am I. Yeah. Okay. So what we have done is that we have taken the size of the nums array and we have initialized the two variables with next 0 and next to 0. Here we can do the previous, and if we are using the previous, then we have to start from the beginning, and if we are using the next, we have to start from the end. Here we started from the iteration from n-1 to 0. So what we are doing is that here, if you are robbing the house, then what we have done is that take the array value and the next to. What is the next to? Next to is the array that you have defined. Next to is the value that is directing to the array value, which is array index, which is the second next of the index. Like you are on the 3, then these are pointing to the value 5. If the size is n, then it can direct to the n plus 2. But we have to keep in mind that we are only solving up to n. Then this is n2, and next one is the adjacent house that we have to rob, and the identic current is the maximum. We can identifying the maximum value from the rob or not rob. That's a peak or not peak. And what we're gonna do, this is a condition for the using these two variables, next to convert into next one, and next one convert into current index. That are solving our problem of time complexity. This is the main reason we have space optimized the solution. And now we have the question. You are in this question, what we have here is that you have arranged all the houses in this circle. Yeah, that's a problem. And okay, so what we have to do is that we have to solve the condition that we are implementing here about the n plus 2, and then we are not caring about the where the variable directing, but we have to take care the boundaries and where we are pointing the variables. Okay, let's take an example. God damn it. Why? Dang. So here we have input 2, 3, 2, and we are getting the output 3. Yeah, got that. Okay, so 2, 3 and 2. That's a nums array, and we are getting output 3. But in the previous question we have getted the output is 4, because if we take this array, this some this index, this value 2, then we can take the adjacent value 2, because this not we can take the non adjacent value 2, then that will be the output 4. But in this case what we have is that this is connected in circle, so they are both adjacent, so we can't do that. Yes, so how we gonna solve that? Let's take an okay, so I'm thinking about the solution that if we exclude the first and last term completely, then this is not a solution, because if we wants to get the solution, if we exclude 2 and the first and end, then this is not a solution. Like if you are getting the maximum more value from here, like you have 9 and you have one more like 2 also, then you can get 2 here, 9 and 2 is equals to 11, and that will be the maximum output, and you have taken the first value, so that's a solution. So okay, let's take another example. Here we have 1 2 3 1. Okay, in this example if we take if we start from 1, if we take it, and then we can take 3, then that will be 4, and if we not take it there, if we take it, and then if we not take it 1 is a 2, if we take it this, if we not take it this, and if we take it that and that, it's 3. The maximum output we can get is 4. Okay, I think there will be a very easy concept behind that, but I can't think of that concept. Okay, here we have a hint. Since house 1 and house n are adjacent, they cannot be robbed together. Yes, that's we know. Therefore, the problem becomes to rob either house 1 minus house n minus 1. Therefore, the problem becomes to rob either house 1 to a house n minus 1 or house 2 to house n, depending on which offer more money. Now the problem has degenerated to the house of 1, which is already being solved. Okay, so we have distinguished into two problems. First is to house, we are taking the house 1, and the other is we are not taking house 2. Okay. There's a first condition for that. Okay, so like here you are getting the time complexity of n 2n. This is a great idea. Okay, something like okay. So what we gonna do here is that we're gonna solve for the both the conditions. Like here we're giving n is equal to num slot size. Okay, and we are returning maximum of what? So in the first we are giving we are starting from like index 1 and to index n minus 1. Okay, like so we are taking maximum and we are giving here is nums and starting from 0th index and ending with n minus 1. And for the second we are getting nums and starting from the position 1 index 1 and ending at position n. So that's the main concept. And what the hell is going on? What's the ruckus? Okay, now we are gonna solve using the 2-parameter space optimized for formula. Like we are taking int next of 2 is equals to 0, the next 1 also equals to 0. We are iterating for loop. We already have I, then we can call it j equals to 0. Now take okay, here we are iterating from n minus 1 to n minus 1 to j greater than equals to 0, j plus plus. And what we are doing here is and also we have to, if n equals to 0, then return 0. Now what we are doing here is starting from say, let's take int pick and nums of I plus next of 2 int node pick nums of I, not the nums of I, only next 1, because we are not taking, we are not taking the index, and then the current I, which is maximum of what, pick and not pick. And if we get any of this pick and pick not pick, then it's window shift. The window shift next becomes the previous next 2 becomes the next 1, and next one becomes the current I, and we will return from this function is next 1. Let's see if it is correct. TLE. What happened? I'm going out of the bound or something. J, yes, that's a J plus plus, but we are using the decrement counter. What? Let's we are getting the solution 6. Why we are getting 6? And for this solution we are getting 4. And for this solution okay, in this solution we are taking 1 and 3 both, but we didn't have to take both. We just have to take the middle one, because okay, I think what the problem here is that we are solving for the okay, we are solving for the conditions. Like in this condition we are not solving for the last term. In this we are not taking the yes, in which we are taking the n. But how are we solving it here is the and like what do I do? We are starting from the n-1th term. Yes. Because array indexing starts from 0 and we are already getting the n-1 for the excluding the last term, not the last week, the out of point term, but we have to well, is this making any sense? Pick not oh wow, okay, so now we are getting the answer 3, not 3, 2, but we need 3 because 3 is the maximum we can get, but here what's going on here is that for the term and yes, let's try it on. That will be the what's the 1, 2 and 3. we are getting 2, but we need 3, and 2 4, we are getting 2 from this, I guess. Let's start from nth term up to we are giving the actual value of n, and here we are again giving the one less value from the n. I don't know what's going on. Let's what we are using j in place of, that's so very blunder. That's a typo. Now we add out. Okay. Yes, we have to check on the 0. Why we are not checking it? And forget about that. Why we are checking here? This is this condition. We will check here. Let's okay, if we have only one index, then this can't work, so we have to exclude this case. Like what we can return is the index 0, because we can't calculate all these function. Now we have done the one of first index. Now we can say that Okay. We don't have to start from the always zero. We are giving the initial value also. Yeah. Yes, that's correct solution. Okay, so like I'm following that. Okay, n minus one, and here I give it giving n minus one and zero. That will work. Okay. Yes, that will also working fine. God damn it. And we have optimized the memory also. Now we will move to 2dp, 3dp and dp on grids. Okay, now this is the problems that are on dp on grids. Ninja training. What kind of training is that? Okay. Let's practice some typing. We didn't need not the YouTube. Okay, and type eraser.
Hey everyone, welcome back to the channel. I hope you guys the first example. 232. Ideally, nothing but lecture 5 is this one. Like temporary 1 contains everything apart from the first element. So I can just keep it like this. Last element, I push everything into the temp 2. Apart from any adjacents, this picket. Now if I try to run this code, you see it is running. Submission time. So always keep your eyes open. And let's follow. Hey everyone, welcome back to the channel. I hope you guys are having extremely.
Okay. So I don't know about anything the 2dp, so I have to watch this lecture. Oh my god, this is a 52 minutes and the 42 minutes followed by dp8. Oh my god. These are some massive videos. Okay. Okay, it's a blue. What blue? First letter wrong. Why am I not? Blue. Savannah. Song. Somewhere. No. Somewhere across the desert. Some. Why I am making so many mistakes? I have to start slow. I can be more efficient. My home is where the heart is. Yeah, definitely. That's where my heart is. Only I send my love to you. much speed is enough, I think. What? Locally data. Bicycle tire. He also earned himself what he earned, a promotion to lieutenant. Lieutenant or lieutenant? How do you pronounce this? I think both are. Pronunciation right. Lots of cargo space by deboning beef. What deboning mean? Beef. It's okay. It's okay to be scared. Yeah, definitely. It's natural to doubt yourself. But yeah, I can't time. I think the second monitor, using the second monitor also impacting my accuracy, because I have always tried typing on my laptop. I don't have to look up, put down, which would ensure when he did. It was so lossy, barely good. Okay, I will be very slow. I don't want to make a mistake. Like why I can't happen with loss and eternity? Why burden would be a torment, and yet why the hyphen not type? He broke the heck breath. Yet what else to call it? This terror, oh my god, terror and this joy. Oh, the why typing is it's a lot, might be, for instance, and the heck with a personal motive for revenge so overpowering that it complete. This is going very good. This was going very good. Now I have fucked up. Or through what I is very difficult to type, and PS wise, why manipulation and elite team of fanatic followers can be trained. Picking up the pieces. Any wonder? Completely. Let's forget about that. This is no going anywhere. Ninja training. Let's watch it.
Well, today is the 7th lecture of the dynamic programming.
Wait. What time it is? Okay, so now we are going to learn about the 2TP concept. Okay, the 2TP means we have to store values in two-dimensional array that will be going to use. And how are we gonna use? Let's see about that. Excuse me. Okay, let's start.
List. And this problem is quite interesting because you're gonna learn a lot of stuff. Yes, trust me, when this video ends, you'll be like, wow, dynamic programming is so super cool. So the question goes by the name Ninja's train. So Ninja is planning this n days long training schedule. Each day he can perform any one of these 3 activities. So there are 3 activities that the Ninja can perform. running, fighting practice, or learning new moves. I forgot about these stuffs. Each activity has some merit points on each day. So there are 3 activities. If you perform any activity on a given day, you get some points. Now, as Ninja has to improve all his skills, he can't do the same activity in 2 consecutive days. That means if on the first day he has done running, on the second day he again cannot run. So 2 activities cannot be done on consecutive days. Something similar to the lecture 5 where it was stated that you cannot pick up consecutive numbers. But over here you have to perform something. Like you cannot skip the next day. You have to perform something. This is where the question is slightly different. Okay? So can you help Ninja find out the maximum merit points that the Ninja can earn if he has n days? Now you're given a 2D array of size n cross 3. It's a slightly different one, n cross 3. Okay, so basically there'll be 3 columns and 10 rows with the points corresponding to each day and activity. The task is to calculate the maximum number of merit points that Ninja can earn. So let me just explain you what does this mean. So basically it means these are the 3 columns. So this is running, this is some activity, second, like I can say first activity, second activity, third activity. This is what I can easily say. And this is day 1. And this is day 2 points. If there was someone else, it would have been day 3. It is as simple as it can get. This is how it looks. So I can say this is definitely a day 1 or 0, whatever you can call it. This is a day 1. Okay. So you have to perform on 2 given days. So greedy again. The first step that always comes to our brain is greedy. So first of all, if I perform on the 0th day, my greedy nature will say on the 0th day, I have 3 tasks that I can obtain with the points corresponding to each day and activity.
Okay, I will read this question by myself.
The task is to
So what is this question is? Ninja is planning this n days long training schedule. Each day he can perform any one of these 3 activities: running, fighting practice, or learning new moves. Each activity has some merit points on each day. As Ninja has to improve all his skills, he can't do the same activity in 2 consecutive days. Can you help Ninja find out the maximum merit points Ninja can earn? Okay, you are given a 2D array of size and is to 3 points with the point corresponding to each day and activity. Your task is to calculate the maximum number of merit points that Ninja can earn. Okay. Okay, so this question is stating that you have to find the maximum merits point, and merits point how we have distributed by their by 3 activities and the days on that we will perform. And for the days we have given the 2D matrix. Like in the given example, if the given points array is 1 to 5, means for the activities, for running we have given the 2, for fighting 3, and the learning new moves is 5 points. But we can't do all the things in we can't do any activity adjacently, means no, one activity can't be adjacent to each other. Okay, means you some activities in 2 consecutive days. Okay, so he can't do one activity in consecutively for 2 days. So for example, like in this example, what are the outputs here? I need to spend for n days. Okay, then okay, no, the 2D matrix is representing here that merits points you can achieve in a day by performing any kind of activity. Like in first day you can achieve 5 by performing the learning new moves, and in the next day you can the maximum merit you can get is 3, which will be running. But if you 3 will be given by the learning new moves and 1 provided by the other boths, then what the condition that you can't take these 3 because you have already taken 5 in the previous day, then you can perform the in consecutive second day the same activity. But here we have the 3 for the running, then we can take 3. And let's see for the next day, then all the activities are giving 3 merits, then you can take anyone that are not previously on previous day you have done. That's the
maximum number of merit points that Ninja can earn. So let me just explain you what does this mean. So basically it means these are the 3 columns. So this is running, this is some activity, second. I can say first activity, second activity, third activity. This is what I can easily say. And this is day 1. And this is day 2 points. If there was someone else, it would have been day 3. It is as simple as it can get. This is how it looks. So I can say this is definitely a day 1 or 0, whatever you can call it. This is a day 1. Okay. So you have to perform on 2 given days. So greedy again. The first step that always comes to our brain is greedy. So first of all, if I perform on the 0th day, my greedy nature will say on the 0th day I have 3 tasks that I can perform. Which one gives me the maximum? An answer that comes up is 50. 50 gives me the maximum. So what I'll do is I'll take 50 and perform it. Right. So that is greedy. Next, on the first day, I know since I performed 50, I cannot perform 100. That is what the question states. If you have performed a certain task, like this was a task, what is like fighting practice something. If this task has been performed, on the next day you can perform that. Yeah, on the next day you can do, but on the exact next day you cannot do. On consecutive days you can perform 2 tasks. So this cannot be performed. So either of 5 or either of 11. So the maximum is 11 that you can take. So 11. If I sum this up, you'll get 61. At max you can collect 61 merit points. But is this the maximum? Now the answer to that is no. This is not the maximum. You did greedily, but you will fail. Why? Because since you did greedily, you took 50. You missed out on something which was much bigger in the next step. So ideally, better would have been if you would have taken 10, correct, and then you would have taken 100. So if you would have taken 10 on the 0th day, like you have performed this task, then you would have performed this task, thereby the total would have been 110, which is indeed the maximum merit points that you can earn. That is what the question states. So we observe that greedy fails. And whenever greedy fails, you know what do you need to do? First thing comes, try all possible ways. Yes, we're going to try all possible ways. That's definitely the first thing that comes to my mind. And whenever I say try all possible ways, the first thing that comes to my mind is much bigger.
Let's note down the example. 10, 50, 1, day 0. What? Okay, let's see what we have got here. Well, that's
Next step. So ideally,
okay.
better would have been if you would have taken 10, correct? And then you would have taken 100. So if you would have taken 10 on the 0 day, like you have performed this task, then you would have performed this task, thereby the total would have been 110, which is indeed the maximum merit points that you can earn. That is what the question states.
Yeah.
So we observe that greedy fails. And whenever greedy fails, you know what do you need to do? First thing comes, try all possible ways. Yes, we're going to try all possible ways. That's definitely the first thing that comes to my mind. And whenever I say try all possible ways, the first thing that comes to my mind is let's apply recursion and try to do every possible stuff that I can do. Right now, if you remember, in order to write recurrence, I've told you 3 steps. What are the 3 steps? Step number 1: express every possible problem in terms of index. Second, do stuffs on that index. Very, very important. Do stuffs on that index. Third, according to the question, like over here the question states find the maximum merit point. So you have to find the max. You find the max. So if you follow these 3 steps, you can definitely write any of the recurrence relationships. Correct? Now, if I ask you in this particular question, can I like over here the question states find the maximum merit point. So you have to find do every possible stuff that I can do. Right? Now, if you remember, in order to write recurrence,
If the greedy fails, then try all possible ways. That is a recursion. Am I making sense?
I've told you 3 steps. What are the 3 steps? Step number 1: express every possible problem in terms of index. Second, do stuffs on that index. Very, very important. Do stuffs on that index. Third, according to the question, like over here the question states find the maximum merit point. So you have to find the max. You have to find the max. So if you follow these 3 steps, you can definitely write any of the recurrence relationships. Correct? Now, if I ask you in this particular question, can I say I can definitely do an index because we have day 0, we can treat that as an index. We have day 1, we can treat that as an index. So the day can be treated as an index because I have to decide on a given day what I'm trying to do. So I have definitely decided what is going to be my index. So I can say, okay, fine. Hey, listen, Striver, we have decided that the day is going to be my index. So that's the first thing. Index is day. Like I'm naming the variable as day, but yeah, that's what overall. So we have decided whatever we are going to do is going to be on the day. On the 0 day, we're going to do something. On the first day, we're going to do something. On the second day, we're going to do something. But whatever we do will be on the index. So first step is done. We have decided the index. Okay. Now before thinking of any other logic, because I don't want you to cram the code. Before deciding anything, let's understand do stuffs. Okay, let's understand do stuffs. So generally, we will be doing recursion, which is definitely
Wait. Making the way. Here we get away. Okay. Well, let's go.
top down, and I generally tend to write it from nth minus 1th index to the 0th index. That is how I do it. You can do it the opposite way, where you take it from 0th index to the nth minus.
What?
Okay. Now before thinking of any other logic, because I don't want you to cram the code. Before deciding anything, let's understand do stuffs. Okay, let's understand do stuffs. So generally, we will be doing recursion, which is definitely top down, and I generally tend to write it from nth minus 1th index to the 0th.
Top down is necessary.
Next, that is how I do it. You can do it the opposite way, where you take it from 0th index to the n minus 1th index. That is absolutely okay. So can I say, let's assume that there are multiple days. Let's assume there are multiple days, okay? And your recursion is somewhere over here. And there are 3 activities on these days. Activity 1, activity 2, activity 3. Now when your recursion is over here, and you have already performed this. In order to select a task over here, in order to select a task on this particular day, ask yourself what do you require. You're like, Striver, in order to perform any of the tasks, like either I can perform this, the task 1, or the task 2, or the task 3, there is something that I require. And what is that something? I need to know what was the last task performed. Like if you're going in this direction, someone has to tell you what did you perform here. Because if someone doesn't tell you what did you perform here, how can you maintain the question? How can you solve the question of not performing 2 similar tasks on 2 consecutive days? Because the question clearly states you cannot perform 2 similar tasks on 2 consecutive days, right? So thereby, Always remember, according to the condition, I repeat, according to the condition, along with the index, you can add a parameter in the recurrence, because over here, in order to decide what stuff I'll do on an index, I need to know what I did on the previous index. I repeat, I need to know what I did on the previous index, because if someone comes and tells me that, hey Striver, previous day I did the task 3, then over here in this I cannot perform the task 3. So someone has to tell me on the last day, what did you do? Yes, what did you do? Because if you don't tell me what did you do, how will I do? Alright, so what I'll do is, I'll have an next parameter, which is last. This is how you solve. Go step by step. You solved index. Then you decided to do a stuff. But then you realized, oh, in order to do a stuff on an index, I need to know what task was done on the last day. Thereby you introduced another variable as last, where you'll say last. That means this task was done on the last day. Got it? That's how you think. That's how you think of recurrence. So we have assigned, like we have done this first step. First step is done of recurrence relationships, which is identifying along with index we need something else. So we identified along with index we need, the last day, the last task, whatever you did. So let's keep it quite simple, because we will be having zero-based indexing arrays. So let's keep it something like task. Let's keep the numbers very straightforward. Can we keep something like assume if I'm passing last as 0 means task 1 was done, or task 0, like the first task was done. If I'm passing 1, the task 1 was done. If I'm passing 2, that means a task 2 was done. Remember, all 0-based indexing I'm not assuming, just to be familiar with arrays. And if I'm passing 3, that means no task was done. No task was done. Again, when will the case of 3 arise? You're very smart. You're very smart, isn't it? When will the case of 3 arrive? Obviously, when you start from the last day, which is n-1 day. Because when you start on the last day, what options do you have? You have an option of performing this task, or this task, or this task. Any task you can perform. And thereby you go across all the possible paths, correct? So that's how you decide. So I can say, initially the call will be made for f of n-1, 3, which states, what does this recurrence means? Give me the maximum merit points, yes. Give me the maximum merit points that you can earn on the array that starts from 0, ends at n-1, and before n-1, you perform 3, means no task were performed. Got it? So if someone writes f of 2, 1, it means give me the max merit points. Give me the max merit points that you can get if you perform the task. Like if you perform the task from 0 to the second index, what maximum you can get in this particular section of the array, given that you performed task 1 right at the third index. This is what f will be signifying. I hope that makes sense. Okay, now let's go on and write the recurrence. So can I say the recurrence will be quite simple? As usual, if I'm starting from n-1, where will it go? n-1, n-2, n-3, it'll go until 0. And 0 will be the stopping point for you, the base case. Very straightforward. Whenever you're solving problems on index, 0 is bound to be your base case. So I can be like, okay, Striver, we have realized that 0 is going to be my base case. Fine, 0 is going to be my base case. Now, can I say if I've reached the 0th index, or probably this push, this guy, there will be 3 tasks over here, right? There'll be 3 tasks. And these 3 tasks, you will have to perform the largest one, which is not equivalent to whatever you have performed here. Make sense? So what I can say is, okay, Striver, let's do one thing. We know there are 3 tasks, and you know that this is the last guy, right? So Striver, do one thing. Just run a for loop from I equal to 0 to task number 2. And if this I is not equal to the last task, probably you can keep a max equal to 0. Can you just give me the max of maxi, or probably you can keep this maxi, comma, whatever task, like assume whatever task you are having, task of I on the 0th index. Although, let's write it properly. There'll be 3 tasks, and these 3 tasks, you will have to perform the largest one, which is not equivalent to whatever you have performed here. Make sense? So what I can say is, okay, Striver, let's do one thing.
Yeah, that makes sense.
We know there are 3 tasks, and you know that this is the last. Okay, right? So Striver, do one thing. Just run a for loop from I equal to 0.
Okay. So what I'm understanding is that you have take the last as a parameter, in which you have the value that tells you about that you have taken the what value you have taken from the previous iteration, means previous day. Like you have done any one of these 3 activities, like running, fighting, and new move, then you can tell by, like, you have index from 0, then you can tell this tells 0, this tells when this is 0, then you have done running in previous stage. If 1, then you have done the fighting, and 3 is the new move, learn new move. Not the 3, 2, and 3, 4, the none of the activities you have done. That will be the case for the first day, because you have not done any activity previous to that day. Yes. Okay, so like you have the function, the day in which you are, and the last that tells you what have you done on previous day. If the day is equals to 0, what that means is, that means that you have starting from the first day. Okay,
Go to task number 2. And if this I is not equal to the last task, probably you can keep a max equal to 0. Can you just give me the max of maxi, or probably you can give this maxi, comma, whatever task, like assume whatever task you are having, task of I on the 0th index. Or rather, let's write it properly. Task of on the 0th day, task I. Whatever maximum you're getting, can I surely return this? Can I say this is my base case? Think properly. Makes sense because you.
Okay, so what he has done here, okay, he have initialized maximum in the condition if you are starting from the 0, if the day is 0th, means you haven't done anything in previous day, the maximum is 0. Yes, that the merit point will be starting from 0. Then you are iterating loop from 0th to 2 to 2 if the index is equals to last. It doesn't equals to last. What does it mean? It means that I think that's a condition for checking, just checking what you have done in the previous day. Like I 0 to 2 is telling us that 0 1 2 what we have, what activity we have done, and if it equals to last, because last we are providing the parameter last, we have to check what that means. And if like if it doesn't equals to last, because it will not equals to last, because we are starting from the first index, and then then we are checking the maximum, or not checking the maximum, we are calculating the maximum by using that maximum will be maximum of the previous maxi and the task, task is a 2D array that is starting from the 0th, that implies that you are starting from the first, that you are on a first day, and I represent that which have the maximum value. Okay, and then you have written the maximum value.
We are having task 0 1 2, correct? You said something was performed on the last day, so during that, apart from that, consider all the other tasks and take the maximum among them and return. Makes sense? Because the last portion, you just, if this was performed, you don't take this, and you take this and this and the maximum of that. Kind of makes sense, right? So you have figured out the base case. Now, if you figured out the base case, I think you have also figured out what will you be doing on that given day. You'll be like, Striver, the best thing that I can do is I can try out performing every task apart from the last task that I perform. Okay, makes sense. So what I'll say is, okay, if you perform something on the last, I'll not perform it. But apart from that, I'll try out all the possible ways. Okay, kind of makes sense. So what I'll do is, I'll say it's the same thing again. I'll keep maximum as 0. And I'll similarly run a loop from I equal to 0 till 2. And I will say, if I is not equal to last. That means if you have not performed this task on the last day, then you can perform this task. Now, I'll just case this because you've understood this quite clearly now. Now, if you're performing a task, can you tell me how much points will you earn if you're performing a task I? That's very simple. On that given day, if you perform the task I, this is the number of points you will earn, correct? And if you're performing this task, you're earning this much points, for this portion of the array, you have to find the answer. But that is something which recursion will do for you, right? So you'll be like, okay, let's go to the previous day. That's a very, very important step. Whenever you go to the previous day, whenever you're going to the previous day and asking the function to find this answer, you have to tell that guy that, hey, I performed the task on the last day. So please tell him that I have performed this particular task. If you perform the second task, tell him you performed the second task. If you perform the first task, tell him you performed the first task. So that whenever this guy is encountered, he doesn't again perform the first task. So you will be like, go to the previous day and tell him that on this particular day, like right before this, you performed the I task, so do not perform that. So can I say the current plus the reduced array is what the total merit points will be, right? Thereby, if I'm doing it on all the tasks, can I say the maximum of all the tasks will be indeed my answer? That makes sense. So I will say, let's return maximum, because that is the maximum merit points that I can definitely make. So if I just keep the recurrence together, this is how it looks. Quite straightforward, quite simple. Just make sure you perform every task.
Okay, so after returning the maximum for the first iteration, when the index is equals to 0, yeah, whatever that means, then what we now we are gonna compute for the section where we have done something in on previous day. Let's we have the maximum is 0, but then what we're gonna do is that travel from 0 to 2, because we have only three conditions that we can perform. And if the index is equals to the last, doesn't equals to last, means you have to perform only that you have done the thing that we have done in the previous day. Yes, that makes sense, I think. And we are calculating the merits or points, that how you call that, you are getting the task means task, the 2D array that representing the merit points. Points you are getting at the day and the activity you are doing, and you are calling the function by reducing day -1 and the ith term, what you have done on the day previous to that, and the maximum, finding the maximum from the maximum of the points you have calculated, and return the maximum. In this solution, what we are doing is that you are starting from the top to bottom, means you starting from the day and day, how many days you have given, like you have given the 10 days to find out how much you can points earn. Then you starting from 10 to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You can also solve from starting from the day 1, days 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how we are gonna follow that solution. Okay,
apart from the task that is performed in the other day. So if whenever you start off with f of n minus 1, you can pass on 3, right? So whenever you are at the last index, which is n minus 1, you try out this task, then you try out this task, then you try out this task, because this will be 3, and the task numbers are from 0 to 2, so you can try out all the tasks when you start off with, right? So this is what the recurrence will look something like. So in order to understand if there are overlapping subproblems or not, or how does the recursion work, just in case you're not comfortable with recursion, let's quickly draw the recursion tree by taking n equal to 4, where this is day 0, this is day 1, this is day 2, and this is day 3. Okay, and the task 0 is like this, the task 0, task 1 and task 2. That is what the points you'll get if you perform them on days 0s and 1s. So ideally what you did was you started from the bottom, like the last row, which is the third row, and you said 3. What does 3 signify? If you remember well, 3 signified that none of the tasks have been performed in the previous day, because this is the last day where you're starting off. So before this there was no days, so none of the tasks have been performed. So what are the options that you have if you're over here? Logically, you can perform either task 0 or task 1 or task 2. That's on you. You can perform any one, right? So what you'll do is you will be like, okay, let's perform the task 0, let's perform the task 1, let's perform the task 2. You try to perform every possible task. So you'll be like, okay, let's go to f of 2, and since you perform the task 0, tell them that you have performed the task 0. Go to f of 2, tell them you performed the task 1. Go to f of 2 and tell them you performed the task 2. Why do you do this? If you're over here and if you're saying you're performing the task 0, so whenever you go to the next day, like the next day, you don't want to perform 10. Thereby you told him, hey, take 0. Do not perform 0. So you will go and perform only T1 and T2, which is task 1 and task 2. Got it? So that's how it will work. Now if I carefully observe, we are at f of 2, 0, and you know whenever there are 3 recursion calls, which one tends to happen first? This one, then this one, then this one. Let's perform f of 2, 0 at first. So if you're at f of 2, 0, that means over here, 0 means you cannot perform this. Thereby, you have 2 options, either this or either this. So you can be like, I can perform task 1 or I can perform task 2. You don't have any other options, or you don't have. So you'll be like, okay, if I'm performing task 1 on day 2, I'll go to day 1, and I will be like taking task 1, because I'll have to tell day 1 that I have performed task 1 in the previous day. Similarly, I have to go to 1, and I'll have to tell him that task 2, please carry task 2. Task 2 has been performed previously. Okay, makes sense. Okay, this recursion will happen first, and then this. Let's do f of 1, 1. So when you are at f of 1, 1, which means you're at here, and you're saying 1 has been performed, thereby you cannot perform task 1. So you can perform task 0 and task 2. Perform it. So you can perform task 0 and task 2. So if I perform task 0, I'll be like, I will go to 0 with task 0. I'll go to 0 with task 2. This is only what I can do. Okay, makes sense again. Now, a very, very interesting question to you. So, where were you? You're like f of 1, 1, and you called something like you perform the task 0. So, if you perform the task 0, what will be the points that you'll add on f of 1, 1? You're performing the task 0. So, on f of task 0, 3. 3 is what you'll add.
Wait. I'm lost.
F of 2, tell them you perform the task 1. Go to f of 2 and tell them you perform the task 2. Why do you do this? If you're over here, and if you're saying you're performing the task 0, so whenever you go to the next day, like the next day, you don't want to perform 10. Thereby you told him, hey, take 0. Do not perform 0. So you will go and perform only T1 and T2, which is task 1 and task 2. Got it? So that's how it will work. Now if I carefully observe, we are at f of 2, 0, and you know whenever there are 3 recursion calls, which one tends to happen first? This one, then this one, then this one. Let's perform f of 2, 0 at first. So if you're at f of 2, 0, that means over here, 0 means you cannot perform this. Thereby you have 2 options, either this or either this. So you can be like, I can perform task 1 or I can perform task 2. You don't have any other options, or you don't have. So you'll be like, okay, if I'm performing task 1 on day 2, I'll go to day 1, and I will be like taking task 1, because I'll have to tell day 1 that I have performed task 1 in the previous day. Similarly, I have to go to 1, and I'll have to tell him that task 2, please carry task 2. Task 2 has been performed previously. Okay, makes sense. Okay, this recursion will happen first, and then this. Let's do f of 1, 1. So when you're at f of 1, 1, which means you're at here, and you're saying 1 has been performed, thereby you cannot perform task 1. So you can perform task 0 and task 2. Perform it. So you can perform task 0 and task 2. So if I perform task 0, I'll be like, I will go to 0 with task 0. I'll go to 0 with task 2. This is only what I can do. Okay, makes sense again. Now, a very, very interesting question to you. So, where were you? You're like f of 1, 1, and you called something like you perform the task 0. So, if you perform the task 0, what will be the points that you'll add on f of 1, 1? You're performing the task 0. So, on f of task 0, 3. 3 is what you'll add if you perform task 0. So, 3 plus, you're calling this f of 0, 0. Remember this. So, whenever this f of 0, 0 goes, it's a base case. If you remember the recurrence, it's a base case. Let's go back to the recurrence. It's a base case. Whenever the day comes to 0, it's a base case. So, in the base case, what did you do? Let's come back. You know this, that 0 has been performed previously. So, either of this or either of this. And you don't have anywhere else to go. So, if this is the only day remaining, then you don't have to think of the future. So the maximum of that is 3. Thereby, this guy tends to return a 3. So this element comes out to be 3. Got it? Similarly, there will be this call, which will be task 2. So if you perform task 2, which is 6, so like 6 plus f of 0, 2. So if you perform this task, you can either take 2 or you can either take 1 on this guy. Thereby, this returns 2. So you will return 2. So this will be 2. Now 3 plus 3 is 6. 6 plus 2 is 8. Which one will you take? You'll be like, let's take 8. Let's take 8. Okay, it makes pretty much sense. So I'll take 8. So I'll just take 8. Perfect. F of 1, 1 is 8. Now we have f of 1, 2. So definitely f of 1, 1 is returning 8. So let's come back to the next solution, which is you're at f of 1, 2 rather. So you're at f of 1, 2. So whenever you're at f of 1, 2, what will happen? You'll be like, let's call f of 0, let's perform task 0. Let's call f of 0, let's perform task 1. That's what you'll do. So again, same thing will happen. If you perform task 0, you will get 3 plus, and f of 0, 0 will return 3. And if you perform f of 0, 1, that's task 1, you will get task 1 for 4. So 4 plus f of 0, 1 will be what? If you perform 0, 1, that means you're coming here and you're saying you cannot perform this. So either of 3 or 2. 3 you'll get, right? So either 7 or 6. Thereby this gives you 6. Perfect. So you're getting 6. Let's not try to write it again. Now you're at here. So whenever you're at f of 2, 0, it states, okay, I cannot perform task 0. Whenever you're at this guy, remember this. It is saying that you are over here, you cannot perform task 0. So either you can do this, which is task 1, gives you 1 point. So 1 plus, you called f of 1, 1, because you performed the task 1. Or you can be like, let's perform 6. So it's like 6 plus f of 1, 2. So either you perform the task 1 or task 2, because task 0 was there, right? So 1 plus f of 1, 1. What is f of 1, 1? 8. What is f of 1, 2? 6. So 9 and 12, which one is maximum? 12. So you return 12. Got it? Now you'll start seeing overlapping subproblems. I hope you've got the basic how the recursion working. So first, I'll just show you one more. So over here, if you are doing the task 1, you'll be like task 0 and task 2. So f of 1, 0 and f of 1, 2. So if you carefully see, do we still see an overlapping? Yeah, this is the first overlapping subproblem that you'll see. So you saw an overlapping subproblems. So if the value of n is larger, you will tend to see a lot more overlapping subproblems. Like over here, if you go t0 and t1, it will be like f of 1, 0. So again, overlapping subproblems over here. Kind of, yeah. So you will, the more you enlarge the tree, you will see overlapping subproblems. And this is how they will solve each other. And after that, you can easily get the answer. So we have again concluded that there are overlapping subproblems. And if there are overlapping subproblems, what do you need to do? You need to do one thing. What is that? Evaluation. Yeah. And what is the easy step? You go back and say, okay, hey function, what are your changing parameters or what are your states? I see there are two states. One is index, the other is day. Oh, sorry, last. One is index or day, and the other is last. There's two parameters for which you have to give an answer. Like we are being said f of n minus 1 3, stating give me the entire array's maximum earning point, given that the task 3 has been done. So two guys dependent. So there was the first guy day, and there's the next guy last. How much is the value day? It can be like 0, it can be like 1, it can be like 2, till n minus 1. So there are n different values that day can have. What is the possible value of last if I ask you on a very simple term? Be like, struggle last can be 0, 1, 2, 3, nothing more than that. So 4 different values, which are 0, 1, 2, task 0, task 1, task 2, and 3, which states that all of these tasks have been performed. None of these tasks have been performed. So there are n4. For every n state, there can be 4 different possibles. Thereby, you'll require an n cross 4 DP size array. Remember this, thereby you'll require an n4 initialized with -1, n4 initialized with -1. And was the first step? Definitely. Over here, you tend to write dp of index last equal to maxi. And over here, just one line, if dp of index last not equal to -1, return dp of index last. 2d dp done. If I reiterate, always the first parameter will be index. Last equal n4 initial
What?
with -1. And was the first step? Definitely. Over here, you tend to write dp of index last equal to maxi. And over here, just one line. If dp of index last not equal to -1, return dp of index last. 2d dp done.
Okay, but he just created a DP of 2D.
Thereby you'll require an n cross 4 dp size array. Remember this, thereby you'll require an n4 initialized with -1, n4 initialized with -1. And was the first step? Definitely. Over here, you tend to write dp of index last equal to maxi. And over here, just one line, if dp of index last not equal to -1, return dp of index last. 2d dp done. If I reiterate, always the first parameter will be index. Next, depending on what stuff you are doing, in order to preserve the condition, you might require some more. And that's when the second parameter is introduced. If you require some more, remember these 3 tricks. You can write any recurrence in the world. So let's try to code this up. What we're given is the n and the points. So I'll try to write the recurrence at first. So the first thing was day. And then the int, and then the vector again, and int, and points. Now, I know one thing for sure, if the day is the 0th day, then I need to figure out the maximum among them apart from whatever was done on the last day. So really, I can keep it as maximum 0, and I can say, I can go across to all the tasks, or rather, name it as task, or task equal to 0, I can go across to task, and there will be 3 tasks, so task plus plus, and we can say maxi. Okay, we just need to make sure this task is not equal to the task done on the last rather. So thereby, this will be maximum equal to max of maxi, comma, points on the day 0, and definitely on the task. So on the day 0, whatever task you're doing, so just make sure you take it off and return the maximum. And if that's not the case, I will be like, okay, maximum 0. If it's any other day, I will perform again the similar thing. Probably I'll be performing all the tasks again. How many tasks are there? Tasks will be this. Value 3. It's like task plus plus. Now what I can do is, if this task was not done on the last day, let's do this task. But if I do this task, how many points will I generate? The points that I'll generate will be points on this day, this task if I perform, plus I'll have to go to the -1 day to solve the smaller sub problem, and I'll have to tell him that, hey listen, this is the task that I did on the current day, I have to pass on the points, so that he gives me the answer. Once he gives me the answer, whatever he gives, or these, I'll take whatever is the maximum. So I'll take the maximum, and once I have the maximum, I can definitely return this one. It makes sense. I think this is looking quite good, so now I can return the function n-1, initially started with 3, and we can definitely pass on the points. That should be fine. So let's give it a run. So as you can see, there's time limit exceeded, so let's memorize it. So that's the way you can create DP variables. DP, and you can pick the first size, which is n, then you can declare the second one, which is vector of int, 4 size and -1. That's how you declare a 2D DP array of n cross 4 in vector. Why vector? Because I generally prefer vectors. It's very easy to pass in reference. That's the only reason. Java people can probably do arrays, not a big stuff. Either way, for Java people, you'll find the code links in the description. Okay. So DP is done, and yeah, you're calling f over here, so you can just pass on the DP over here. Right over here, you can say DP of probably day, and then there's something as last, so you can just give it like this, and right before returning, just make sure you check it across. If DP of day last, this subproblem has been previously solved. If this subproblem has been previously solved, what you can do is DP of day, and you can say last. Please return that, and now let's code this up. It gives me a correct answer. Now let's quickly submit this. As you see, I was solving this before this class, and yeah, it runs. So we used. Recursion does memorization in order to solve this particular problem. Now it's time to check out the next possible stuff, which is tabulation, just in order to reduce the stack space. So what's the next step? The next step is 2D DPI and one initially start with 3 and we can definitely pass on the points.
So what we have here is in this recursion solution, like you have taken the day, the last and the dp. If day equals to 0, then what you gonna do? Start from the maximum 0, traverse all 3 tasks, if task doesn't equals to last, then you can find the maximum. By the maximum and points to it. Take any one that have the maximum. And return the maximum. That's for if you have only one row. But if you don't, then similar steps. If dp you have for loop, we are running a for loop. let's see there.
It's the last. Maybe it's written that.
Tabulation.
And now this class, and yeah, it runs. So we used recursion plus memorization in order to solve this particular problem. It's time to check out the next possible stuff, which is tabulation, just in order to reduce the stack space. So what's the next step? The next step is tabulation, because the recursion, as we saw, we were using something like the time complexity of memorization will be n crossed, because see, there are n cross 4 steps. Understand how many different states we can have? That's n cross 4, right? Like not in all cases we'll have 4 states, but yeah, let's assume for the worst case it's n cross 4 states that we can have. If you carefully observe, for every state we were actually running a for loop of size 2, like for every state, or size 3 rather. So for every state you're running a for loop of size 3. So I can say it's n crossed 12 is the time complexity, and space complexity of big O of the recursion stack space will be n, because at max you'll go for n days, but the space complexity will be n crossed 4. So this will be the recursion plus memorization time complexity, and this is an extra. Yes, this is an extra that you have to omit, and this you cannot reduce. So how can we first omit this recursion stack space? So we will be doing something as definite, which is tabulation. What did I tell you? What's the first rule of tabulation? Declare the similar size. Yes, declare the similar size DP array. That's the first thing that you'll do. Kindly declare the similar size DP array. Next, whatever base case you have written on index 0, right? You've written on index 0. Now, whenever you're doing 2Ds, because these are 2D DPs, right? Whenever you're doing something as 2D DP, what should you keep generally in your brain? What can be did whenever you come across here? Try to think in this perspective of base cases, okay? So that's the trick. You'll be like, Striver, over here, index, if it is 0, either last can be 0, or it can be 1, or it can be 2. So I can say there are base cases like 0, 0, 0, 1, 0, 2. In all of these recursion calls, do you agree? In all of these recursion calls, or 0, 3 rather, like, in all of these recursion calls, do you agree that this base case, yes, this particular base case will be executed? You agree, right? Because if index is 0, no matter what is the value of last, they will be executed. Now let's analyze. What if it is 0? If it is 0, then you end up taking the maximum of task 1 and task 2 if it is 0. If it is 1, you end up taking maximum of task 0 and task 2. If it is 2, you end up taking the maximum of task 0 and task 1. If it is 3, which might be the case if there is a single day, then you might directly call 0, 3. You will end up taking task 0, task, all these guys maximum. So can I say the first form of tabulation will be nothing but, I can simply write that as dp of 0, 0 will be max of, so max of array of the 0 on the 0 day, task 1 or task 2, right? Similarly, the dp of 0, 1 will be max of array of task 0 and array of day 0 task 2. Similarly, dp of 0.
I ain't gonna lie, the tabulation part is kind of tough. You have to convert all the solution in the DP format. That's kind of tough. Let's
2 will be max of array of 0, 0, array of 0 task 1. Similarly, dp of 0, 3, like I'm just writing it like this. You could have used the similar for loop to write it. Like, anyways, while writing the code, we'll do that. This was done in order to explain you. So these are the base cases. Base cases are done, right? Now what's the next thing? The next thing is this. You have to convert this into a DP solution. Now, this portion of the code, is executed when the value of this particular day becomes equal to 0. So equal to 1, 2, 3, 4, and so on till n minus 1. Whenever this becomes equal to this, you execute that, correct? And what can be the possible values of last? I again ask you the same question. And to that, you will be like, Striver, it'll be like similar to 1, it can be 0, it can be this, it can be this, it can be this. Okay, makes sense. For 2, it can be 0, it can be 1, it can be 2, it can be 3. For 3, day 3, it can be last can be 0, last can be 1, last can be 2, last can be 3. Right? So we can definitely follow this. So thereby we know for every day. So let's first write the code for day. So if I know that I'm going to start, because what is tabulation? Previous class, guys, what is tabulation? Tabulation is nothing but bottom up. So from 0 to the up. Like if I show you the recursion tree, you'll start from here, then you'll compute this, then you'll compute this, then you'll compute this. Bottom up, recursion top down. This is what you require as the answer, but you go down, then you figure the answer. Top down. Okay. So what I know is, let's come back. What I know is I have I equal to, or I can say day equal to 1, and I'll go on till the day n minus 1. Now over here, can I say for every day, there are 4 different task values, 0, 1, 2, 3, 4. So I can say for every day, there are 4 different task values from 0 to 3. Okay, makes sense. Done. And once you have written the for loop, it's just copy pasting the recursion part. Once you have written the for loop, it's just copy pasting the recursion part. So whatever was written over here, yes, whatever you have written over here, just copy paste. I just copy paste that. So I can say now you have to perform task, correct? So if this is, or you can say this is last rather instead of task, you can say this is last. So can I say over here you just copy paste? What did you write? You wrote I equal to or task equal to 0 to 2, and if like you just compute it, similar, just write the similar stuff. Like it's getting a bit messy over here, but you can write the similar stuff. Like instead of f, it'll be dp of day minus 1, and I is basically this guy. That's what it will be. So what I'll do is I'll try to write this in code, and then I'll come back again because it's absolutely getting messy over here. So in order to write the tabulation, what you will do is you'll declare dp array of n cross 4, and super quickly write something like 0 on 0, with max of definitely points of 0 of 1, points of 0, 2. That's very obvious. And similar, I can just copy paste this thing for the other tasks, which is task 1. So if you're doing task 1, this will be 0 and 2. And if you're doing task 2, this will be definitely 0 and 1, correct? And for the last guy, it's very simple. It'll be 0 and 3, which means all the tasks. Just take all the tasks. Simple as that. So max of points of 0, 1. That's what you can definitely do. So yeah, figure all the 3 guys. So that's the basis. Now what did I say? Where does the day start from? The day starts from 1 till n. So just go until n. how many last can you have per day? Number of last that you can have is definitely from 0 till 3. So you can just go on last plus plus. Now what did I say? Just copy paste whatever is written over here. Whatever is written over here, just try to copy paste the stuff. Okay, so let's copy paste this stuff in terms of task. You see me copy pasting. Okay, so I need the maximum. Now remember, what am I looking to compute? I'm looking to compute dp of last, correct? So then we can keep this as 0. So we're trying to compute it. Okay, and assume sorry, assume I'm taking a maxi variable. At the end of the day, whenever I'll compute this, okay, at the end of the day, whenever I'll compute this, I'll store maxi. How do you convert the records? See, I'm gonna copy this exact same thing for identity task. I'm not copy pasting because the indentation will go wrong. Task, there are 3 tasks, so I'll just go like this. What is written over here? If the task is not equal to last, right? I write the same thing. See, I'm writing the same thing. Task not equal to last. How many points does it gather? Point equal to points of day task. Same thing. See, same thing. Plus, instead of f, and you're doing bottom up, this f would have been computed and stored in your dp. So dp of day minus 1, very good, comma task. So take this off. Okay, done. Next, you'll update maxi equal to max of maxi, comma point. So out of all points, whatever you got this, you just take it across. So instead of storing maximum, what you can do is you can directly store it in the dp. That's the better version. So you store it in the dp, and yeah, you just keep it dp of day last. Then just using a maxi variable, what I did was I just used this particular stuff. So I'll just comment this. And where is your answer? Was the initial call that you made to recursion? The initial call that you made to recursion was f of n minus 1, dp of n minus 1 and 3. So just made it, you just make it. And now what you can do is you can definitely run this. And you see this running fine. Yeah, ready, just submit it. Was tabulation tough? Or was it tough? If you would have written recursion. No, it was not. I told you in the starting of the DP playlist. Once I teach you DP, you'll never forget it. So that's how I wrote the wonderful recursion. I just told you how to make sure the first couple of for loops are written. Once for loops are written,
Let's see this part again. What it has to offer us. Ninja training. What we have done here is it going to solve for the space optimization also?
whatever is the recurrence, how do you just write them?
Yeah.
Once you write them, you get your particular answer. That's how simple it is. So it takes a time complexity of big O of n cross 4 cross 3 because there are 3 loops. So what I can do is, previous, instead of day minus 1, I can directly take it because I'm concerned with 4 values. So I can directly take it. Once the temp is computed after this entire iteration, what I can do is, I can say, okay, temp has been computed. Now let's make the dp as temp. And this dp of day minus right in the dp. That's the better version.
Let's try to understand it. So what he has done is he has created a 2D array that calls dp of size n for the row, and the column size is 4, and all these values have all the indexes have value 0, and here and what we have got here is that dp of okay, that dp, the 0th index, represent giving the value maximum of the points from the points of 0 1 and point 0 2. Okay, Okay, all these four conditions for the finding the maximum for the first term. That just okay, like this dp for the zeroth index, which is representing the zeroth column, and the column represent the first day. The zero, this is the day. That tells you that you have only one day to find out the maximum points, and for the maximum points you can uh, uh, what you can do is that uh, to find compare uh, all the three activities with each other and get the value, and all the time as all the tasks are same.
So you store it in the DP, and yeah, you just keep it DP of day last. Then just using a maxi variable, what I did was I just used this particular stuff. So I'll just format this. And where's your answer? What's the initial call that you made? To recursion, the initial call that you made to recursion was f of n minus 1, f of n minus 1 and 3. So just made it, just make it. And now what you can do is you can definitely run this. And you see this running fine. Yeah, right, just submit it. Was tabulation tough? Or was it tough if you would have written recursion? No, it was not. I told you in the starting of the DP playlist, once I teach you DP, you'll never forget it. So that's how I wrote the wonderful recursion. I just told you how to make sure the first couple of for loops are written. Once for loops are written, whatever is the recurrence, how do you just write them? And once you write them, you get your particular answer. That's how simple it is. So it takes a time complexity of big O of n cross 4 cross 3 because there are 3 loops, and the space complexity is still n cross 4. We have eliminated the recursion stack space. But how do you eliminate this? That's where something as space optimization comes in. Yes. So let's learn. Now, if I show you the code, how do you determine that there can be a space optimization? Whenever you see a DP of day last is actually using something like point, and if I just cover this off, like I can just write it over here, which is nothing but this. Like I just write it in one line, which is this. DP of day last is nothing but max of some DP of day last, comma something plus something, right? Now this something is a previous state of DP of day minus 1. Now remember, whenever you're computing DP of day last and you're taking day minus 1, so that's when you can space optimize. Whenever there is something like minus 1, minus 2, then we can think of space optimization. Let's see how. So specifically, how did this problem, how was this problem solved? Like if there are multiple days, we created a DP array, right? Of like assume over here n is 5, and there were DP arrays something like this: task 1, task 0, task 2, task 3, and the days were like 0, 1, 2, 3, 4, 5. So initially what you did was, initially you filled these guys. I'll show you in the code. That's what you have done over here. Right? This is what you've done. You've initially filled them. Right? Then you went on to fill this. But when you were trying to fill this, what was the line that you wrote? So let me just write it over here so that I don't have to again switch and switch. Last equal to something plus DP of day minus over here so that I just fill them. Right? Then you went on to fill this. Initially you filled these guys. I'll show you in the code. That's what you have done over here. Right? This is what you've done. You've initially filled them. Right? Then you went on to fill this. But when you were trying to fill this, what was the line that you wrote? So let me just write it over here so that I don't have to again switch and switch. Last equal to something plus DP of day minus 1 comma task. Right? That's what you wrote. So basically, if I carefully observe, what can be task? Task can be anything like this. So in order to compute this row, what did you require? You required this particular row's values because day minus 1. Either this value, either this value, either this value, either this value. This is what you require. So assume you computed these guys, and then you move to the next day. What did you require? When you're trying to compute the row 2, you just require these values. There is no more requirement of these guys. It's not required. Using these values, you can actually compute these guys. And then again in the next, using these values, you can again compute these guys. Then again on the next, using these values, you can compute these guys. And again, when you go back, this guy is your answer. Correct? So, do we need to store an entire array? Can't we do something like this? Let's start off with a very small array. And what we do is, we store this guy over here. And then create a dummy size 4 array and try to compute them. And then again, store it. And then use this to compute the next. And then again, store it. And again, use this to compute the next. Then again, store it. And then compute the last. And then this will be the answer. Can I do this? Can I just store a size 4 array? If I just store a size 4 array, I don't require an n cross 4 array because there's no need to store previous information. Because what I require is just the previous guy. Thereby, I'll do a space optimization now. So I'll be like, I don't need the entire thing. So what I'll do is, hey, why can't I just do this? I think I can definitely do this. I will be like, I'll declare a size 4 array. And I'll make the, see, I just made it. The first 4 is declared. So what I can say is, this is declared. The first 4 is declared. Next, I'm at DP. So instead, now what I'm doing is, I'm trying to compute the current day, which means I'm trying to create this. So what I'll do is, I'll simply keep something like this. Vector of int temporary of size 4 is what I'm looking to create. And what I'll do is, instead of DP, I'll just create temporary. Okay, so this is for the current one. So the current day will be stored in temporary. And this DP of day minus 1. Now I know the previous is this current DP, like the previous guy. So what I can do is, probably in order to name it better, so that you understand, we can just make it previous. So the previous row is over here. So what I can do is, previous, instead of day minus 1, I can directly take it because I'm concerned with 4 values. So I can directly take it. Once this temp is computed after this entire iteration, what I can do is, I can say, okay, temp has been computed. Now let's make the DB as temp. So that again on the next day, when this guy has been computed, this can serve as for this guy, and we can again compute this. So we keep on doing. And at the end of the day, instead of this, I can say, the previous has my answer. This will be previous. The previous has my answer. Right? And once the previous has your answer, you can definitely run it. Let's see if it runs. Yeah, it runs. And now let's try to submit it. It runs. Look at the time. 4:26 AM in the morning. And I hope I was able to make you understand. And the time complexity now was, so the current day will be stored in temporary. And this DP of day minus 1. Now I know the previous is this current DP, like the previous guy. So what I can do is, or probably in order to name it better, so that you understand, we can just make it previous. So the previous row is over here. So what I can do is, previous, instead of day minus 1, I can directly take it because I'm concerned with 4 values. So I can directly take it. Once this temp is computed after this entire iteration, what I can do is, I can say, okay, temp has been computed. Now let's make the DB as 10. So that again on the next day, when this guy has been computed, this can serve as for this guy, and we can again compute this. So we keep on doing. And at the end of the day, instead of this, I can say the previous has my answer. Oh, sorry, this will be previous. The previous has my answer, right? And once the previous has your answer, you can definitely run it. Let's see if it runs. Yeah, it runs. And now let's try to submit it. It runs. Look at the time, 4:26 a.m. in the morning, and I hope I was able to make you understand. And the time complexity now boils down to n cross 4 cross 3, but what about the space? I'm just using a 4 size, which is as good as constant, I converted a 2D matrix to as good as constant, like 1D, again cross 4 into 4, which is very, very good. So that's about the space optimization. I think I'm gone with first because it's a very, very long video. So guys, I hope I was able to explain you the entire problem, all the 3 approaches. Just in case I was, please give me a like, because it takes a hell lot of effort to make this content. And please do consider commenting US, because that tells me that, okay, the people who are watching the video are understanding it. This is please